All right, guys, I hope everyone is doing well. Last week, we started learning how to set up a single trait Punnett square, or also called a monohybrid Punnett square. Today, we're going to be working on page 7 of our Punnett square packet. You'll notice that on page 7, the crosses are a little bit different because you're not given all of the parent information. You're only given some of the parent information, but you are given some information about the offspring. So we're going to see how we can set up these Punnett squares with only having partial parent information. That being said, at the top of the paper, you see a key that shows you the traits we're working with. So there's pod shape, there's pod color, flower position, plant height. These are all traits that are seen in key plants. So for pod shape, dominant with a capital N would be smooth, or constricted would be recessive with a lowercase n. And so on with pod color, we'll use G. Flower position, we'll use A. Axial means along the stem. Terminal means at the end. Think of a long stem rose. Plant height, tall or short, we use that already with a capital and lowercase t. So we're going to start with number 1. We'll see that some information is given about our parent and some information is given about our offspring to help us figure out. In some cases, we'll figure out all of the information about the parents. In some cases, only some. We'll start with a key. So we see we're working with a tall plant and a short plant. So we're going to go up to our top here and get our key. Capital T equals tall, and lowercase t equals short. And there's 2 ways to approach this problem. You can do kind of trial and error, so take an educated guess what you think the parents might be, and then try it. And if it works, then you have it. If not, you try a different cross. We're actually going to go a different route and kind of work backwards, fill in what we know, and then see if we can figure out the rest. So we're going to start with our tall plant. We know that if the plant is tall, it is dominant, and therefore it must have a dominant allele or a capital letter T. We don't know the second letter, so our parent could either be homozygous dominant or heterozygous. We're not sure which one is the case from the information given. That is crossed with a short plant. In order to be short, the parent must be homozygous recessive, so only have recessive alleles, and therefore the short plant must be little t little t. So far that's what we know about our parents. So I'm going to fill that in here and leave this blank for my second allele for the first parent. I'm going to set up a basic Punnett square. And fill in what I know about my parents. So again, my first parent I know is dominant. I do not know the second allele, so I put a little line there to denote that. And then my second parent is short and therefore homozygous recessive. I'm going to fill in what I know here, and I'm going to look at the rest of the problem to see what I'm given. So I leave a little bit of space there to form my second allele for these 2 blocks. Okay. Notice if we continue to read, we see some of the offspring are short, which means not all of them, but some of them. So if we look at our offspring, we can see that we have some tall offspring here. About 50% of the offspring we know will be tall, but we don't know what the other 50% will be. If the offspring is going to be short, then we can see that these must be short, or at least one of them. It doesn't have to be both, but at least one of them. So I'm going to go ahead and assume that this one is going to be short, and I'm going to see if I can figure out my parents from there. If this offspring is short, then one of those recessive alleles came from this left parent, which would be the homozygous recessive parent. The other one must have come from the top parent, which was our dominant parent, the tall plant, which means we can fill in the rest of our Punnett square now and then fill in the rest of our information. So this parent is heterozygous, not homozygous dominant. If the parent was homozygous dominant, we would not have any recessive offspring. The offspring genotypes, we only have 2. We have heterozygous and we have homozygous recessive. Okay. Our phenotypic ratio, remember, is how many are dominant compared to how many are recessive in our offspring or the F1 generation. So we have 2 that are showing the dominant, which is tall, and 2 that will be short or recessive. The numbers 2 and 3 are similar in that you are given some information, but not all. So I'm going to ask that you pause the video now and see if you can figure out 2 and 3 and come back and check and see how your answers are. All right, so I started setting number 2 up for us just to get a head start. So if you need some guidance, maybe you could take a look at what I have here and then pause the video again to try and finish it on your own. Notice we're using axial is dominant, terminal is recessive. If 3/4 of our plants are axial, right here, and 1/4 is terminal. Notice this looks a little bit like, so 3 and 1 looks a little bit like our phenotypic ratio. So that means 3 of our 4 need to be dominant, where only 1 is recessive. Good place for you to pause if you want to try and figure this one out from here on your own. I'm going to continue though. So our recessive, we know that means that each parent had to pass down a recessive. Now we can kind of do trial and error to see, what else we can figure out. So here we know that if we have a dominant, then this other allele must be the recessive from this parent, which tells me that the dominant came from this parent right here. Same idea here. We have a dominant here, which means the recessive came from this parent, but the dominant came from this parent. Look what I have already have it filled in, and now I can just double check. So I have my 1, 2, 3 to 1 ratio, which would be 3 dominant to 1 recessive, and that matches my 3/4 are axial, and my 1/4 is terminal. So my parent genotypes are heterozygous and heterozygous. You might notice trends. So if you're getting really comfortable with monohybrid Punnett squares, you'll notice that a heterozygous parent times a heterozygous parent always gives us a 1 to 2 to 1 genotypic ratio and a 3 to 1 or 75% to 25% phenotypic ratio. We'll move on to number 3, which I started setting up also. Go ahead and pause the video and give this one a try. I started with our key. Notice that we do have 1/2 of the offspring are green and 1/2 of the offspring are yellow. Good place for you to pause. All right, so if half of our offspring are dominant and half of our offspring are recessive, we'd have to set it up like this. We don't know the other allele if the parent is dominant, but we do know both alleles if the offspring is recessive. So taking a look at the 2 offspring that are recessive, I can tell that I have a small g here and then a small g from this parent. Again, this offspring will give me a small g from that parent and a small g from this parent. To get homozygous recessive, I need to receive a recessive allele from both parents. That means that dominant here came from the first parent on top, which gives me a heterozygous times a homozygous recessive offspring. So trial and error is one way, but we actually did the fill it in and then come back to kind of pick up the pieces where we left off. One thing to keep in mind is to remember, for now, make sure that you use a capital and lowercase. It's very easy to go capital and then pick a different letter for the lowercase. Just be really careful that you consistently use capital and lowercase of the same letter for that given trait. Next video, we're going to work on page 8, which is all about test cross.